Welcome all to my YouTube channel Shweta Gupta Chemistry Classes. Today we'll be covering the topic Empirical Formula and Molecular Formula. These topics are from the first chapter of class 11 Chemistry, some basic concepts of chemistry. So the first one is Empirical Formula. Now children, if someone asks you about benzene, then the formula of benzene is C6H6 and the empirical formula for benzene will be CH. That is, if you multiply CH with 6, you get benzene C6H6. So, it is generally telling you this empirical formula of benzene is CH. So this empirical formula is the chemical formula of the compound which expresses which expresses the simple whole number ratio of various atoms of the various elements present in one molecule of the compound. Here it is representing the simplest ratio. It is representing the simplest ratio or simplest whole number ratio of the elements which makes the formula C6H6. That is, it gives you for one molecule of benzene, that is C6H6, for one molecule of benzene, one carbon atom is present for each hydrogen atom. For one carbon atom, there is one hydrogen atom. As you can see, for 6 hydrogen atom, there are 6 carbon atoms. So, this is what empirical formula is. So, it gives you the atomic ratio of various elements present in the molecule. It gives you the atomic ratio of the various elements present in a molecule. So empirical formula of a compound is the chemical formula which represents the simplest whole number ratio. It represents the simplest whole number ratio, that is CH for benzene. That is, it gives you the ratio 1:1. For each carbon atom, there is one hydrogen atom. Or for each hydrogen atom, there is one carbon atom. So, in benzene, there are 6 carbon atoms. So, for each hydrogen atom, there is one carbon atom. So, the number of hydrogen atom are also 6 here. So, for this, the benzene, the empirical formula is CH. In the same way, for hydrogen peroxide. Children, hydrogen peroxide is having the formula H2O2. And the empirical formula for hydrogen peroxide is HO. That is, for each oxygen atom, there is one hydrogen atom. If you multiply OH with 2, you get H2O2. That is this OH is the empirical formula. It gives you the simplest whole number ratio between the two atoms of the element which are present in a molecule of a compound. I just hope this one is clear. Now the next one is molecular formula. Children, what empirical formula is? ये आपको सबसे ईजी वे में बताता है कि एक एटम के लिए कितने नंबर ऑफ सेकेंड एटम प्रेजेंट रहेंगे. इट जस्ट गिव यू द आइडिया ऑफ फॉर ईच एटम हाउ मेनी एटम्स आर प्रेजेंट. इट गिव्स यू द सिंपलेस्ट होल नंबर रेशियो. इट डू नॉट गिव यू द एक्चुअल फार्मूला. ये कभी भी आपको एक्चुअल फार्मूला नहीं देता है. इट जस्ट गिव्स यू द सिंपलेस्ट होल नंबर रेशियो. कितना छोटा करके आप किसी भी कंपाउंड का फॉर्मूले को लिख सकते हैं सिंपलेस्ट होल नंबर रेशियो में, ये वो होता है. नाउ नेक्स्ट वन इज मॉलिक्यूलर फॉर्मूला. So the molecular formula of a compound is a chemical formula which represents the true formula of its molecule. Like for benzene, children, the empirical formula is C6. The molecular formula is C6H6. That is, the molecular formula gives you the exact or the true formula of a molecule. And it gives you the actual number of atoms of any element. That is, this formula, molecular formula, gives you the exact number of atom of carbon and give you the exact number of atom of hydrogen in benzene. So it gives you that 6 atoms of carbon are there and 6 atoms of hydrogen are there. That is, it gives you the exact number of atoms of the elements which are present in one molecule of a compound. So it gives you the true formula of the compound, that is molecular formula. Now children, next is relationship between empirical and molecular formula. There is a relationship between empirical and molecular formula. Molecular formula is equals to n into empirical formula. Now children, n into empirical formula. N is any integer. It can be 1, 2, 3, 4 into the empirical formula. Like, I'll give you one example. In case of benzene, what will be the molecular formula? Molecular formula will put the value of n over here. In benzene, the value of n, that is integer, is 6. And empirical formula of benzene is CH. So the molecular formula of benzene will be 6 into C will be C6 and 6 into H will be H6. So the molecular formula of benzene is C6H6. So molecular formula is equals to n into empirical formula, and this is how we do it. Now, how we find out the value of n? N is molecular mass upon empirical formula mass. N is equals to what, children? Molecular mass upon the empirical formula mass. Generally, if in question molecular formula is asked, then they will give you the molecular mass. What you will do? You will find out the empirical formula, then you will find out the empirical formula mass, and in the question only molecular mass will be given. Then you will be able to find out the value of n, and then you will be able to put the value of n into this formula of molecular formula, and you will get n into empirical formula. That is, you will get the molecular formula. So the relationship is molecular formula is equals to n into empirical formula, where n is equals to molecular mass upon empirical formula mass. Now children, will be doing one numerical, very important, very important. These type of questions are generally asked in your exams. Find out the empirical formula and find out the molecular formula. So the question is, a compound contains 4.0% hydrogen, 24.2% carbon and 71.65% chlorine. In this, a compound is made up of hydrogen, carbon and chlorine, and the percentage of the elements are given in the question. Its molar mass is 98.96. Molar mass is also given. What are its empirical and molecular formula? So on the basis of the data given, children, you need to find out the empirical and molecular formula. So there are some steps which are involved in calculation of empirical and molecular formula. So the steps is, first you have to write the name of the element, that is hydrogen, carbon and chlorine. Then you have to write the symbol carbon, hydrogen and chlorine. Then you have to write the atomic mass of element. You know the atomic mass of carbon is 12, atomic mass of hydrogen is 1 and atomic mass of chlorine is 35.5. In the same way, you have to write the percentage of element. Percentage of element is for hydrogen 4.07%, for carbon it is 24.27%, and for chlorine it is 71.65%. So first element, then symbol, then children you have to write the percentage, then the atomic mass of element. 4 steps are clear. element, symbol, percentage and atomic mass of these elements. Next one is you need to find out the moles of element. Children, what you have learnt about the formula of moles? Moles is mass in gram divided by molar mass. So, we'll generally write the percentage in grams. I have already told you this. We generally write this percentage in grams. So, you percentage or gram means same. So, first you will write the mass in gram divided by molar mass, or here you can make it out the atomic mass, molar mass or the atomic mass. So percent moles of element will be equals to what, children? Formula is percentage given divided by atomic mass. So it is 24.27 divided by 12, it is equal to 2.07. And here percentage divided by mass, atomic mass, it is 4.07. In the same way, percentage divided by atomic mass of chlorine will be equals to 2.02. Now, after calculating the moles of element, children, you need to find out the simplest molar ratio. The simplest molar ratio. To find the simplest molar ratio, first thing is, in the moles of element, find out the lowest number. Moles of element, 2.02 is the lowest number out of these three. 2.02, 4.07, 2.02. So the lowest number out of these three is 2.02. Now the simplest molar ratio is this moles of element divided by the smallest number. Smallest number but among these three is 2.02. So moles of element divided by smallest number is equals to 1. Again, moles of element divided by the smallest number. Smallest number is again is 2.02 is equals to 2. Again here the moles of element is 2.02. 2.02 divided by smallest number. Smallest number is 2.02. So 2.02 divided by 2.02 will give you equals to 1. So now the simplest whole number ratio came out to be 1, 2 and 1. So it means carbon is 1 atom, hydrogen is having 2 atoms and chlorine is having 1 atom. So the empirical formula of the compound becomes CH2Cl. Now we know that we just now have done this. Molecular formula is equals to N into empirical formula. Empirical formula just now we have calculated, and to find out the value of N, the formula is molecular mass upon empirical formula mass. Now children, what is empirical formula mass? Empirical formula mass is calculated for the empirical formula. So empirical formula mass of CH2Cl is equals to, for carbon atomic mass is 12 plus for hydrogen atomic mass is 1 into 2 atom, 1 into 2 plus for chlorine atomic mass is 35.5. So the empirical formula mass of CH2Cl is 49.5. So we got the empirical formula mass, and in the question the molar mass is given 98.96 gram. So we'll put the value in this. N is equals to molar mass, that is given in the question 98.96 divided by empirical formula mass we just now calculated 49.5. It came out to be 2. Now the formula for molecular formula is N into empirical formula. N came out to be 2 and empirical formula came out to be CH2Cl. So you'll be multiplying 2 with CH2Cl. So C multiplied by 2 gives C2. H2, 2 into 2, 4, H4 and 2 into Cl will give Cl2. So C2, H4, Cl2 is the empirical formula of the compound. So I just hope this question and this topic is clear to you all. In case of any doubt, you can write in the comment section. Thank you and have a nice day.